Okay, so guys, shall we start? I'm audible. Just confirm one more time. Then we'll start that.
Yes,
Yeah? Okay.
yes,
Yeah.
Okay. So before
Yeah.
start the session, you guys are working professionals, right?
yes.
Okay. So
Yes.
what's the current profile? So you guys are working the containers technology or something like what? Accordingly, I can start that.
Okay, so I will start. So my name is Madhu Kaira. I'm working with BMC Software.
Mm-hmm.
So my designation, I mean, even Vijay's and my designation, we both work in same company. So we are technical analysts. Yeah, we do work on Docker and Kubernetes, but not that much. Okay, so we don't know what is this OpenShift, and yeah, we know little bit this containerization stuff,
Contain.
but
Okay.
not in
Yeah.
yeah
Okay. Okay. So
yeah,
containers
but
technology,
not
you guys know that. Okay. Mm-hmm.
yeah, but not in deep level. So if whatever you would like to cover to
Mm-hmm. Okay. Got
let
your
us know
point.
understanding, that would be great. Yeah,
Okay. Okay.
thank
Got your
you.
point. Yeah. So Vijay, the same profile you guys are working, right? In your
Yeah,
team.
we work in same team. Yes.
Okay. Okay. No worry. Okay, so what we have inside this course container and all those things, right? So in the 280 or we can say DO280, this like a training course and all those things, right? And this
Mhm.
exam course and all EX280. Okay, so don't worry about the code and all those things. What we can say, we have options, we have a terms.
Mhm.
The DO280, this is like a training code when you're talking about the training. Okay, the OpenShift training. Let me write those things. The select training code. Similarly, EX2, that's for the exam. We can say that's like certification or exam code. Okay.
Okay.
Now, so in the 280, what we have actually, just like a, the course designed for that OpenShift, or we can say containers management, or we can say another word, just like a orchestrations of your container, like the admin who are going to manage, maintain your entire OpenShift infrastructures, right? Let's suppose you guys have a lot of containers and all those things. You are managing those containers with the help of Docker or Podman command, right? With the help
Hmm.
of that, we can manage only one container, right? When we talk about
Yeah.
the lot of container, thousands plus container, because in the real world, in the software deployment or in the productions, each and every application, we have a containers, right? To managing those applications, to managing those containers, what we need, that we need a that type of tools, technique, mechanisms that manage your containers automatically, right? So we have like Kubernetes earlier, even though we have a Kubernetes as well. So we have like Kubernetes and OpenShift as well. So Kubernetes is also like a platform, tools, open source software that manage your containers, right? In same way, we have a OpenShift that is for the enterprise application level and all those things, right? That is managed and maintained by Red Hat. In other hand, Kubernetes is managed by Google. It's like open source project, right? That's like a
Okay.
basic things. Similarly, when we're talking about the exams and all those things, so what we have in the exam in the EX280, so that's like a 3 hours exam, okay, right? Just
Okay.
like a practical based exam, so don't worry about the exams and all those things. We have a sample for the same, we'll cover that. So total we have 3 hours exams, okay, and total we have a 16 questions in this particular exams and all those things, okay. Total 300 is total mark, and to pass those score, you guys need to at least minimum 210 as a passing score, okay.
Okay.
So that's like a
Okay.
basic things. Don't worry about the exams and all those things. So we are mainly we are going to focus on training, right? And when we complete those training and all those things, then we'll discuss about the exams preparations as well, okay. So don't worry about that, okay.
Okay.
Now, so jumping on the our environment and our technology, what we have that. So similarly, officially when we're talking about the course content, so total we have like 9 chapter, okay, in the DO280, or if we can say the OpenShift Administrator Part 2, we have a like 180 earlier, right? Now it's expire. Now we have a 280, right?
Okay.
Earlier we have a 188 as well. That is for the development and all those things. And now we have like 280 and all those things. That is like a administrator, like how you can manage, maintain, apply the securities feature and all those things over your OpenShift infrastructures, right? In other platform we can known as a RHOCP, right? We can say Red Hat OpenShift Container Platform. That's like a terms. We can say this like different terms. Now,
Okay.
So the first thing what we are going to learn inside these things, the first we are simple talk about what is container, what is Docker and all those things, what is Podman, all those things, right? Why we are going to use this particular OpenShift, or we can say what the advantage of using the OpenShift and all those things, right? Okay.
Yeah.
So before these sections, right, just let me know quickly like what is Docker, Podman, and then containers, quickly, guys.
Okay. So I just have one
Hmm.
question before that,
Uh-huh.
Satyendra. I mean,
Uh-huh.
is this session would be recorded?
Correct. It's a
So if
recording. We will
okay,
share
yeah,
the over the LMS, right? Do
yeah,
one
yeah.
thing
Okay.
after these
Oh,
sessions.
okay.
Yeah, after these sessions, you guys just created account over this portal lms.webasha.com. Okay, and just share
Okay.
your username over the WhatsApp or any method you can share with me, right? What I
Yeah,
can do,
yeah.
I can just simple approve from the backend. Okay, just simple create account over that.
Okay.
Yeah.
Yeah, sure. Thank you. Yeah.
Okay. Yeah. Okay. So what is Docker and Podman, guys? Or we can say what is Docker and container?
Okay,
Or
so I
the
will take that Docker. Yeah.
mm-hmm,
So
mm-hmm.
the Docker, it is containerized engine. I mean, there are many containerized engines. So Docker is one of that. Like RKT is also there. Then CR is also there. CRO, sorry, CRO is also there.
Cryo, you mean
And
CRIO?
yeah, Cryo, yeah,
Yeah. Mm-hmm.
CRO, yeah.
Mm-hmm.
And then this Docker, yeah. So like that way, you would like to cover Podman, Vijay?
Podman, it's like a Docker only, which
Mm-hmm.
hosts containers.
Correct.
Like a container may be a package of software that contains all the necessary applications to run any environment.
So what is container then? Is it like
Uh,
application, all those things? Mm-hmm.
uh, Container is like a package of softwares.
Package of software. Okay. And then Podman, it's like a simple, like I need only a single differences, like the difference in the Podman or Docker we can say, and then containers. So container you mentioned that it's like a collections of software, correct?
So container,
Yes.
we can say a
Uh-huh.
small VM, okay,
Correct. Correct.
which is
Okay.
running, which required containerized engine to run, and Docker and Podman, that is the containerized engine. Podman
It's a
is owned
command,
by,
yeah. Okay,
yeah,
correct. Yeah.
it is from the Red Hat,
So
and
simple we
Docker.
can say, yeah, okay. The
Mhm.
simple we can say in the single word, Docker and Podman both are a command, tool or utility that manage your containers,
Okay.
right? And
Mhm.
container is simple we can say it's like a box in non-technical way we can say that store all the informations. Information means we can say the file system, the libraries, the inode number, everything, right?
Mhm.
That help to build or run your applications.
Mhm. Yeah,
Right?
got it.
Yeah. So simple we can say Docker and Podman both are like a containers management tool, or we can say it's like a tool. With the help of these tool, we can create, delete, manage, maintain your containers. Containers is like collections of your all the dependencies, all the packages, all the datas, inode, file system structures, everything, right? That help to build your
Mhm.
applications, right? Like earlier, let me draw a diagram with you guys to clear these things, right? So when we're talking about the software deployment and all those things, right? So we have like a different mechanisms to deploy those software, right? What we have in the earlier, or we can say in the traditional way, again, like again, you are working in a company and your company asks for you to deploy an application. So what you need to do, simple, you have a like hardware we can say, right? And over
Mhm.
there, what we have that operating system, right?
Yeah.
And then your application. Just like a traditional way we can say to deploy an application. So that we can say that is a traditional method to deploy an applications. Clear with that?
Yeah.
Similarly, in another word, what we can say, we have like different another options when we're talking about the software deployment, right? So let me write those things. Why is not typing those things? Okay, so what we have that we have a like hardware, then we have a like operating system that could be anything when we're talking about the OS, that could be your Linux, Windows or any OS, and then we have our applications. Okay, so that we can say that is a traditional way to deploy an applications. Correct? Now
Yeah.
another word we have, another hand we have a virtualization mechanisms, right? In when we talk about the traditional way, what we have there over the single OS, you can deploy multiple application. That's correct, not a problem. But might be if any application goes down, or might be they have some problem and all those things. So that could be problem with your another applications as well, because we have some dependency and all those things, because all the applications running on the same host. So that could be a problem, right?
Yeah.
Now, what we have that in the virtualization method, right? When we're talking about the virtualization method and all those things, so in that case, what we have that mechanism are remain same. Let's suppose we have again hardware. These things we require that, okay. Then we need our operating system, okay. Then what I need that I need some kind of hypervisors mechanisms, right? In the
Hmm.
virtualization, what we have that we need that type of mechanisms, or we can say what is hypervisor, or we can say it's like a mechanism that split physical devices into virtual with the help of different hypervisors tool, like VMware, VirtualBox, and then we have a KVM, then we have a Hyper-V, or when we're talking about the physical hypervisor, then we have like ESX and ESXi, correct? So these like are physical, these like a hypervisor. With the help of hypervisor, we can split physical devices into virtual. So environment remains same. Let's suppose we have like hardware, okay. Over the hardware we have like operating system. So if you need, then you can directly deploy or install your application over the OS. But what I need, I need a split, or I need a different or independent virtual machines to deploy a single applications, right? So as you know that we
Yeah.
cannot directly install, yeah, so we cannot directly install OS over the OS. That is not possible, right? So what I need, that I need type of mechanism, or we can say mediator. Here we have a hypervisors. What we have that hypervisors, right? That could be anything, like let's suppose you have a like KVM, VMware, anything. I'm not sure about, so I'm not discussing about the hypervisors yet, but yeah, depend on your availabilities and your expertise, you guys can use any kind of hypervisor. Let's suppose you have like VMware, that is managed by VMware Incorporation. Then we have like VirtualBox, that is managed by Oracle. Then we have a KVM, that is managed by Red Hat. Then we have a Hyper-V, that is managed by uh, Windows, I mean Microsoft, okay. So there are a lot of hypervisors, so you can install any kind of hypervisor. That could be your VMware, VirtualBox, or anything, right? Now these hypervisors allow to create number of virtual machines. It's like what we can say, it's like your VM virtual machines,
Yep.
correct, right? So we can say like, yes, these are my VMs. Inside this VM you guys can configure your application. We can say we have VM1, okay, VM2, VM3, and VM4, right? Inside that you guys can deploy your application, like we can say we have app1, we can say app2, and all those, right? If anything goes wrong in the VM1 and all those things, other machines are remain same, is working fine, so the problem will not impact on any another system. Clear? The process
Yeah.
remains same in the physical, or we can say in the traditional method, or in the virtualization method. What we have that in the both, we are creating independent VMs and all those things. We are creating independent machines, right? The advantage of in this particular virtualization, if anything goes wrong in any particular VM, right, this problem is not going to impact on any another applications or any another VMs, right? But again, you need to create a VMs, you need to install your application, everything you need to manage manually and all those things,
Yep.
right? Now, correct. Now in the next point, in the container method, because we are talking about the application deployment, right? How we can deploy our applications efficient with the help of different tools and mechanisms, right? So what we have in the container method, or when we're talking about this mechanism, we can say we have a container method, okay, or a containerized method. What we have, so let's suppose point remains same. What we have, again we have a hardware. These things are persist, so we can say again we have like hardware, okay. Over the hardware, what we have, that we have operating system, okay. Then what I need, that I need a container engines to create what, to create multiple containers, right? So that
Yep.
could be your Docker, or that could be your Podman, okay. So over the OS, either you can directly deploy your application in that traditional way, either you can deploy that particular virtualization method, that is also possibility. But I need that I need to create a multiple containers. So container, another hand, we can say it's like a small VM. It's not exactly VM, right? When we're talking about the managing those VM with the help of hypervisor, so that known as a VM. But again, when you're talking about the containers and when you're talking about managing those applications, what I need, that I need a any container engine. So in that case, what I'm going to do here, I'm going to deploy, or I'm going to install container engine. Correct?
Yep.
Okay. So container engine could be anything. That could be your Docker, or that could be your Podman. Correct?
Yeah. For Docker container engine, we only say Docker, or we say Docker engine.
I didn't get. Come again.
For the Docker engine, we only say Docker or Docker engine.
Correct. Docker and Docker engine both are same. It's
Oh,
not
okay.
like
Okay.
differences. They like a wording actually. Command or Docker, right? To manage
Yeah.
those things, we have an engine. So you can say that
Okay.
Docker engine both are same. It's not a difference or something. Okay.
Okay.
Correct. So now this Docker engine allowed to create multiple what? So this container allowed to, this command allowed to create multiple containers.
Yep.
Correct. So we can deploy multiple containers with the help of different mechanisms and different way. Okay, just a second, please. Just a second.
Yeah, sure.
Okay, clear. So what point we have that, right? Okay, so what point we have that, like again, we have a hardware OS, and then we have a like a container engine, we can say. That could be your Podman and Docker. We'll discuss about the difference between Docker and Podman. Now, so this Docker container engines allow to create multiple containers, right? So container, we can say, is like a box in non-technical, we can say, that store every information or everything, right, that help to build, run your OS, or we can say applications, right? The point remains same. We have like a Dockers, and then we have a containers and all those things. Inside this container, what we have there, we are running our applications right now. So what's the difference between the virtualization, because traditionally is a different thing right now. So what's the difference between virtualization method and then container method, when we're talking about those things, right? So in the virtualization, what we have that, again, if you wanted to deploy an application, you need to install a VM from the scratch, right? In the particular container, it's not required, right? It's like a small packet, or we can say we have like containers images. It's like a more lightweight than the VMs and all the traditional way. You can simple, within a single command or single click, you can create your containers, right? In the virtual method, you need to specify the hardware resources. I mean, you need to fix that, the hardware resources for the, like we can say, for the CPUs, memory, RAM, and all, storage and all those things, right? In the case of container, right, all the containers use the same hardware resources that is provided by your administrator and all those things, right? By default, we are not going to specify the hardware resources. We can say CPU, memory, right? We'll discuss in the next topic that we can say limit ranges, but by default, what we have that, what the default behavior, again, all the containers using the same hardware resources. No need to specify or no need to fix the hardware resources. Clear with that?
Yep.
Right? So again, what we have that we need some kind of, in the case of virtualization, we need a kind of hypervisor and all those things. In the case of container, it's not required, right? It's use the same kernel to managing those or separating those different containers. By default, each other containers we cannot communicate with that. By default, with the help of communication, all those things, it's like independent. Okay, we need to configure some bridging network, some networking model. We'll discuss that, but again, we have mechanisms again, right? The process remains same in the case of virtualization. In the case of container, the advantage of container, we can run more application, we can create more container compared to the virtualization, right? Same thing in the case of container, the process, that process that you want to run, that only process that going to run that. But in the case of virtualization, or in the case of traditional method, the lot of, or we can say the unwanted application should be run. Why? Because that could be your OS dependencies, right? But in the case of containers, not required, right? The like what admin want, right? That process you can run that, except of any other process and except of any other techniques or technologies. Clear with that? So the process remains same. We have a different method, different way to managing those things, right? So let's suppose, like I'll share with the ebook with you guys, okay? So I'll just show you that the differences and all those things. We have an ebook for the same. It's like a official ebook. I will share with you guys the basic differences between the containers and then the virtualizations, right? If you check these doc, okay, so they clearly mention all those things. I'll just quickly go through that. Okay, so these are like a comparison, right? So what we have that, we have a virtualization. So what I need that, I need our OS, then I need our hypervisors, then what I need that, our OS and then applications, correct? I'm talking about this parameter. Similarly, in the case of containers, what I need that, I need a OS and then the runtime packages or runtime environment. We can say the Docker engines, or we can say container engine, and over that we have our applications, right? And there are some differences between the containers and virtual machines. What difference we have that enable the multiple OS run at the same time over the single hardware. Yeah, that's a possible in the case of virtualization as well, and in the case of containers, right? But for the same, you need to use any hypervisors to divide your physical devices into virtual, correct? And require a complete OS installations to support your application or to run your applications, right? Like let's suppose you are admin and your developer ask for a machines, right? That should be installed some application like Java and all those things. So in that case, you need to create a VM first, and then you need to install your operating system. I mean, you need to deploy your application and all those things, right? Another hand, in the case of containers, we don't need to do that. We have multiple options. Either you can either you have options, either you can create a containers and then install your application, either you can uh, install and I mean create and install both at the same time, right? So that's a like possibility. Same in the case of container, what we can say, run directly on the OS, right? Sharing the same hardware resource across all the OS and all those things, right? So this enable applications to stay lightweight and run or deploy quickly. Okay. Similarly, share the same OS kernel isolated with the different containers mechanism that is managing by your Docker and Podman. You can deploy those things. Okay, and require a fewer hardware resource than the virtual machine, which also make them quick to start and stop. Clear? So the same point what we have there, Docker and Podman both are a command that manage your single containers, right? When you're talking about the lot of containers, more than 100,000, all those things, what I need that, I need a that type of tool, or we can say container orchestration tool that manage your containers applications, right? So in that way we have a different tools. We can say we have a Kubernetes, what we have that Kubernetes, and then we have a OpenShift. Clear with that? So before start this Kubernetes and OpenShift, I'll just quickly go through this environment, like how we can create a containers with the help of Docker and Podman command, right? And in that we'll discuss the difference between the Podman and Docker, right? So let me start my lab. Okay, I think you know the concept of Docker and all those things, right? Like how to create a container with the help of Docker or Podman command. Okay, let us start and we'll start that. Okay, so let's suppose what we have that. Okay, we have a hardware, we have a OS, and then what we have that we have a Docker and Podman. So for the same thing, you guys need to install the any container engine. We can say Docker or Podman. Again, if you're using a RHEL-based machine, you guys simple can install yum install Docker. Either you can deploy a Podman. Correct, right? Again, in the Debian based machines, what you can use, you can use apt install. Either you can use simple command, you can say a Docker, or then we can say Podman. Either we have a for the different distribution, we have a different URL. So simple, you can explore Docker installation point. Okay, these things are not in the course contain all those things, so you can, if you need, then you can simply skip that. But again, wanted to install, then you can install that. So what point we have that you have a different flavors, right? Like you are using a CentOS, Debian, Fedora, RHEL, Ubuntu, and all those things. Accordingly, you can choose. Let's suppose I want to install on the CentOS, then simply select the CentOS, and these are steps. With the help of these steps, you guys can install a Docker, right? In the
Yep.
RHEL, what we have that, in that case, you need to enable, again, you need to enable the repository, and then simply install a Docker. It's a freely available. Okay, so now what point we have there, the difference between the Docker and Podman, right? So earlier we mentioned that, right? Earlier we mentioned that both are a container management tool. With the help of both command, we can create, delete, manage, maintain our container. So what's the difference between them? Okay, so we can say Docker, we can deploy, we can run any OS platform over the Windows, Linux, or anywhere, just like choices, right? Podman is specially designed for the RHEL based machines, we can say for the Linux based machines, right? That is managed by Red Hat. Just like basically both are open, so it's not about that, right? Now, the main difference is that if you wanted to manage your container with the Docker command, the service should be active and running. I'm repeating again what?
Yep.
If you wanted to manage your container with the help of Docker command, make sure the container, the Docker service, we can say systemctl restart and Docker, that should be active and running. In the case of Podman, it's not required. Correct? In the case of
Okay.
Podman, it's not required, right? You can directly, it's like we can say daemonless, right? Again, Docker need to start, that should be active and running, but in the case of Podman, it's not required. You can run a Podman images, Podman ls, and all those things command. That's going, that's running fine without restarting the service. So we can say Docker is like a daemon dependencies, we can say, but in the case of Podman, it's like a daemon less, right?
Okay,
And all
you mean the Podman? Sorry to interrupt. So you mean the Podman? It is just binary, like
It's a simple
kubectl.
binary, yeah, simple binary, simple yum install Podman and then just run the command like Podman something something command without restarting the
Oh, okay,
services.
okay,
Right, but in the case of Docker, if you want to run something Docker command, Docker something, then make sure the service should be active and running. If it's not active, then we cannot fire the Docker ps command or something command. It's not going to
hmm,
provide some output and all those things, right? So I'll show you
okay,
that example with you guys. Okay, in the case of our course content, we can say in the case of OpenShift and all those things, preferably Red Hat using the Podman command, right? So
okay.
that's the point. In the case of rel based OS, or we can say in the case of productions and all those things, in the case of OpenShift, we have a Podman inbuilt in application inside that. That's the possibilities.
Yeah, but what underlying containerized engine Podman will use, since it is you said it is daemonless based.
No, no. The Podman is like a, it's like a still. I mean, it's the same. It's like a Docker is a depend on that. Now we can say dependency. It's like a upstream versions, right? It's like a Kubernetes and OpenShift, right?
Hmm.
So process remains same, okay? Because Docker also is like a open source. Podman is also like OpenShift, right? To manage those applications, to reduce resources and all those things, Red Hat implemented an application that we can say a Podman, right? All the
Yeah, agree.
process, yeah, all the process and everything remains same, because again, if you wanted to run an application and all those things, right? Or you just start any services, that service needs some sockets and all those things to store or to run those applications, right? And it's
Hmm.
required some resources, right? To
Hmm.
run or to stay lightweighted, all the applications, all the containers, even though the container engine, Red Hat managing those things, we have tools that name is Podman, because we will discuss about the nodes and pod, right? That manage
Hmm.
your pods or that manage your containers. So to stay lightweighted, we don't have any kind of daemon, right? But again, when you start those services, it's by default running. No need to start it manually. That I'm trying to say that.
Okay. No, no. My question was when you install Docker, right? So it is daemon set because it install the container engine also. So, but in case of Podman, it is just binary which you need
No,
to
no.
keep in
Container
USR.
engine. No, no. Container engine means what? I didn't get actually. What you are trying to say.
So in
Uh-huh.
OpenShift, which containerized engine they prefer, like
So
CRO?
yeah, they're using a cryo and container D.
Oh, okay, got it. Yeah, yeah.
Container D actually, right?
Container D. Yeah,
Yeah,
got it. Thank you.
because in the Kubernetes we have options for the same. So by default we have a Docker, we are managing those things manually, right? Even though
Yep.
when you're talking about the installation of those things, they clearly mention that you need to install this container D and all those things,
Yep.
right? So when install those manually, it by default install the container D, right? And when you're talking about our Kubernetes infrastructure and all those things, we have a cryo, or we can say container D, even though in the Kubernetes as well, container engines, okay?
Okay.
Yeah, so what I'm trying to say, let's suppose in my case I think we already installed some packages. I think Docker package in my case is installed. Okay, so what I'm trying to say that you wanted to run something command like Docker ps, make sure the service should be active running. So in my case, if you notice on that, we are getting error message,
Hmm.
right? But even though in my case by default Podman installed, in my case if I run this Podman command like Podman ps, right, the process is not required, we can run the command like that, daemon is not required, right? So
Okay.
again, if you wanted to manage run your container with the help of uh, Docker command, make sure service should be active and running. Okay, start the services and start it. And if you want to start it permanently, then just simple enable that. Okay, and then
Mhm.
try to run command something like Docker ps and all those things, and anything like that. That's a process and nothing else.
Okay.
Okay, the command remains same, Docker ps, Docker images and all those things, or even the command remains same, right? But simple what we have that, instead of the Docker we have a Podman, or simple vice versa we can say, and all the process remain same,
Yep.
correct, right? So again, if we wanted to create an application with the help of these particular environment, then what we have exactly, we need to install the Podman and all those packages. Okay, so command remains same. Let's suppose I wanted to create an applications, right, over the Ubuntu OS and all those things. What I need that in the traditional way, first you need to download the Ubuntu images, we can say ISO images, right? Install those OS and then install your application.
Yeah.
In that way, in our way, what we have that, what I need that, I need a kind of container images, we can say, right? Container images, we can say, is like a customized template, right? That have only informations that manage or that allow or that help, we can say, to run your applications, right? Even though when you're talking about the traditional ISO images, that could be like when you're talking about the Ubuntu images, right? Ubuntu ISO images, that size could be might be 4 to 5 GB. I'm not sure the size, but yeah, that could be 4 to 5 GB ISO image, right? When you're
Yeah.
talking about the container images, or we can say container image in the case of Ubuntu, that could be maximum like 18 to 100 MB, I guess. Why? Because that have only the information that help to run your application. They don't have any unwanted kind of application that could be using some unwanted resources as well. Okay,
Yeah.
right? So same thing, wanted to deploy an applications, so we have options, either download image first and then create a container. Either when you create a container and if in your system the image is not available, then it will automatically download it from the some portal, we can say some public repository, right? So we have some trusted repository, we can say, that could be your Docker Hub, right? That could be
Yeah.
your q.io, we can say QA, or most of the time they are mentioned the qa.io, right? We have like redhat.io, a lot of things we have that, we can say we have like redhat.io, okay, access.redhat.com kind of thing, okay. We have a centos.org, right? We have like Fedora, so a lot of different portals, right? That could be a public or private. Even though if you are an organization, then the organization have their own private repository from over the GitHub GitHub, or might be SVN or somewhere else, Bitbucket and all those things that could be over there, right? So
Yeah.
similarly, wanted to deploy an application, the first thing I need to download the images, right? It's not required, but again, if in your case the image is not available, then first is download and then recreate that. So let's suppose I wanted to verify some images, okay. Okay, so let me delete something, like I guess in my system, just a second, let me delete everything. Okay, so let's suppose I don't have anything, right? Even though I don't have any images yet, I don't have any running container, I don't have any stop container, correct?
Yeah.
Now I wanted to create an Ubuntu containers. The first thing I need to download the images, right? So again, I mentioned that we have different portals, we can say we have a Docker Hub and all those things, right? So in that case, I wanted to verify, let's suppose Docker Hub and all those things, just like a freely available portal, right? And let me search, I want to download something Ubuntu, right? So is Ubuntu are available or not? If you notice on that, we have a Ubuntu official images, right? They downloaded 1 billion plus, downloaded 10,000 plus rating and all those things. It means just like in good enough and all those things. And what command they mentioned, that they are mentioned Docker pull and Ubuntu. That command they also mentions here, correct?
Yep.
Now, so what command we have, that again, if you want to download some images, so I just mentioned that you can use the command like Podman, or you can use the Docker. So Podman pull and then Ubuntu, right? So how your system will recognize that, like I need to download the images from this particular repository, from the Docker Hub or something somewhere else, right? So whenever we install these packages, I mean the Docker engines, we can say, or container engines, by default we got a configuration file. What we got, that we got a configuration file, right? Inside this file they mention that from which portal you are allowed to download the different images and all those things, you can mention that, correct?
Okay.
Right? So here when we run this command like something podman pull and Ubuntu, right, your system will search the freely available portal, like from, again, if you are downloaded from somewhere else, you need to log in with your credential and all those things, right? From the Docker Hub you can download anonymously, I mean without login. So same, if I don't want to download that, just run this command podman pull Ubuntu, it will automatically search that, right, from where you wanted to download it, hit enter, right? If you notice on this, trying to download from the Docker, right?
Yeah.
Just a second, Make sure internet should be accessed inside your machines. In my case, I think let's not access. Just a second. Let me allow public interfaces in my system because we are downloading applications from the public. Okay, so it's pinging now. Let me run the command again. Okay, so if you notice on this, it's trying to download that, right?
But where is the authentication setup, or
No,
it is
so
open for
Podman,
everyone?
no, no. So yeah, so earlier I mentioned that you can download without credentials from the Docker Hub, right?
Okay,
From the other portal, you need to download yourself. You need to authenticate yourself, right?
okay.
For the pulling, it's not required. You can pull without authentication. We can say anonymously, anonymous, okay?
Hmm.
But you wanted to push, I wanted to upload, you need to authenticate yourself.
Okay,
Correct, right?
yeah.
So again, you wanted to pull those things, you need to log in with the command like podman login and something docker hub, or we can say docker io, prompting for the username something and prompting for the password, right? Then you can authenticate yourself with the over that particular portal, right? But again, for pulling those things is not required.
Yep.
Sorry, clear with that? So after download those things, right? After download, we wanted to verify those things. Here we got image, the size of only 18 MB. If you notice on that, just like images. Again, it's not like a traditional images. No need to install from the scratch. It's like a by default install and all those things. Simple. Attach these container image to your VMs, or we can say our containers. So that's like container images, and we need to attach with here in our
Mhm.
containers. Correct? You can use this command. Either you can use podman image ls command to check the images and all those things. Correct?
Yep.
Right now, wanted to create an applications with the help of these container images. What command we have that? So command remains same. Like suppose podman run hyphen it hyphen detach hyphen name. So that name, we can say a container name, that could be anything, okay? And from which images? Ubuntu, right? So what we are
Yep.
saying, what we are doing here, we are creating a container with the name of VM1 from which image? Ubuntu, right? In the detached mode, we can see in the background, right? Just hit enter, right? In our case, we have a locally Ubuntu image are locally available, so no need to download that. If this image is not available, then you need to download from the, system automatically downloaded from the scratch, right? Wanted to verify, here we have a containers. So container ID, from which images, and the name of your containers.
Hmm.
Clear? Wanted to go inside this container to perform some tasks, like we created these things. Wanted to go inside and perform some tasks, then what command we have there? Simple, podman execute hyphen it in which machines VM1, then give me a shell, hit enter. Now we got some shell.
Okay. What is this latest?
Oh, this is like a tag, image tag, versions
Okay,
we can
okay.
say,
Yeah,
right? We
yeah,
have a
got it.
like this, like a tagging. Correct, right? So which machines we are inside that? So you are inside something Ubuntu OS and all those things.
22.4.
Something,
Okay.
right? Because our base OS is something different. We're not talking about the my physical machines. That might be rel 9, okay, I guess OS release. Okay, so yeah, I'm using a rel 9,
Oh,
right?
okay.
And that we created these machines. Container. That is my Ubuntu based machines. Okay, something is wanted to perform some task, even though you can create something files and folders. So it means what? We are performing the task inside this container.
Hmm.
Clear with that?
Yeah.
Right? So the command remains same. What command we have there? Podman. If you not mention this name argument, again I'm mentioning, if you not mention the name argument, your system, your kernel will automatically provide you a name, right? Random, any random name. I'll let you know. What command
Okay.
we have that? Podman ps, here we got a something random name, right?
Yeah.
Now problem is that we cannot change the name with the help of Podman or with the help of Docker.
Okay.
Again, one more point about the why we are using mostly why we are using the Kubernetes or OpenShift, right? If we have any running existing container is running fine, then we cannot modify or change something. Let's suppose I wanted to allow them a something port number and all those things, then we cannot do that. You need to delete, or we can say terminate, and then recreate an application, right? But in the case of Kubernetes, in the case of OpenShift and all those things, we can modify or we can change your containers. Correct?
Yeah. Hmm.
This also a advantage and disadvantage of the particular Docker and all those things, right? So again, if you're not mentioning the hyphen name argument, that we're not going to create the name, we have something a random name, we'll get that, right? Now the next one what we have, that again we mentioned that if we, let me remove all those container running containers. So podman rm hyphen a with forcefully, it means we are removing the containers. Okay, so again we have not any containers yet. Okay, so we have not any containers yet, or even though we have not any stopped container, right? And even though, let me remove the images as well. So we have not images as well. Now the point what I mentioned, that if we have existing images, and if I run this command like podman run, and the name I just mentioned, the hyphen name something vm2, it means what? It means your your command will search for the local containers, local images. If these images are available, then it will create a containers for you. It will create a containers for you, right? But in my case, I don't have these images available, right? So first it will download the image and then it will create a container.
Okay.
Correct? Let me show that. Hit enter. If you notice on that, it's trying to download first. Okay, and
Yeah.
then it will create a container. So point remains same. If you have an existing locally images available, then it will create that. If not, then just like a point, we will create those images and all those things. Okay, so if you notice on that, it will download and it will create a container. Then now we got images as well. If you notice on that, we have podman images, and then we have podman ps and all those things. Clear with that?
Yep.
Right? Similarly, wanted to create a container in the publicly, or we can say any port number and all those things. The command remains same, but you need to mention those port number. So command remains same, like hyphen it. Okay, hyphen name I mentioned that that name could be like public VM something. Okay, and then hyphen p, we are mentioning the, we are publishing the port number, right? So we can mention something port number like 80,000 something like that. It means what? We can say that is my host port and
Machine
that is
port.
my container port, correct?
Yeah.
Right? And then from which images? Ubuntu. Clear?
Yep.
Hit enter. If you notice now, podman ps, here we got a, for all IP version 4, right? If traffic come over 8001, it will automatically provide to a port number 80 and all those things. Correct?
Yep.
Wanted to deploy something, wanted to do something, then simple go inside this machine with the help of podman execute hyphen it in public VM, and then give me a shell bash. Now wanted to some deploy something, wanted to update something, right? So if you notice on that, we are successfully allowed to access internet inside which machines? Inside my public VM containers. Right?
Yeah.
Wanted to deploy an application like apt install something, let's suppose Apache 2 and applications, let's suppose. Okay, so we are successfully allowed to install an application from the external world, right? Because we allowed the publicly, these machines are in the public. Okay, similarly wanted to run something application, all those things, you can run those applications. Let's suppose I'll give example as well. Let's suppose that is my document root, and here I just mentioned something message, like I mentioned that this is test page configure from or we can say docker something. Okay, start the service, like we can say service, just for the example, service apache 2 restart. Now if you notice on these machines, let me launch an browser to access those applications, right? We are using a locally so far now. Okay. Correct. So if you wanted to access those machines, so we have like we are using the locally. So I just mentioned that localhost colon which port number. So you are running on 8001, right? So your application is accessible. Correct.
Okay, yeah.
Right. So the process remains same. If you want to change something, like again wanted to modify something, then again you can mention some extra message like that. Okay. No need to refresh one more, or no need to restart the services. Just simply refresh that. Your changes will automatically applied. Okay. So the process and everything remains same. What we are doing here, we are simple running an application over the container based, right? And whatever you make changes that are running over this machine. Similarly, you have a built-in application. We can say I wanted to deploy an applications, like let's suppose I want to deploy an Nginx, right? What process we have that either download Nginx first, right? It downloaded from the Docker hub, or we can say Docker IO, and now with help of Nginx you can create an containers, right? You can also allow them a publicly accessible. Clear with that? So process remains same. We have a OS plus applications. Either we have a single application. So depend on that, like what application wanted to use that. So let me show that. Like we have this images Nginx, right? And with the help of Nginx, if I just create a container like Podman run -it detach, and then I'm just mention the name something like VM3. Allow them public like 8000 something 2 on 80 port number with the which application Nginx, right? If you notice now we have an applications, or we can send a container Podman PS, the container running on which port number 8002, correct?
Yeah.
Right. So if I just use the browser, and here I'm just using something local host, and which port number 8002, here we got an Nginx application. That's simple. That's a process. Correct, right? So with the help of Podman and Docker, right, you guys can maintain or manage your container, but at a time only one container you can manage that, right? If we have like lot of container, like now, like let's suppose we have a 3 containers, right? But again, if you're like a 3000 or something like more than these quantity and all those things, right? So to automate or to manage automatically, for the self-healing, for auto scaling, for all those things, we can say we need a type of tools or mechanisms that help or allow to create or manage your containers automatically,
Mhm.
right?
This first port, it is machine port, and 80 is.
The left one is for your host, and then that one is for the container. It means, I'll just a second, I'll give you the details. What we have our environment, right? You have a physical system, we can say, right? Inside that we have a containers, correct?
Yeah, yeah.
Now you are in public or something like that, right? And you have a customer. Let's suppose you have your customer. Okay. Now this customer wanted to access your applications, right? So we cannot directly connect to this machine directly, because it's like a inside this container, right? So what I'm mentioning that is my physical node and that is my container node, right? So what I'm mentioning that is my 8000 something port number, right? We are mentioning, or we are telling to this particular node, we are, if traffic comes over 8001, right, it forward to the which port number?
80.
Something 80 that we did earlier,
Got it. Yeah, yeah.
right? It means what? It means if in traffic come on 8001, what we are running that here, we are running the command like what? Something local host, right? Or IP, or we can say, and then which port? 8001, right? So that transfer to the port 80, whatever packet you have, that is accessible. Similarly, if you just mention that something local host kind of thing 8002, right? So traffic comes on 8000 port number, then you have to mention that if traffic comes on 8002, right, it's a different port number, then forward to another container. We can say another container that running on the same port number, not a problem, because they are independent, they are free.
Yeah, yeah. Yep.
Clear with
Got
that?
it.
Yeah, so the left one we can say that is your for the host, or we can say your physical machine's port number, and the right one is your container port number.
Got it.
Correct, right? That's a process, that's a way, right? You cannot run the same like 8001, 8000, we cannot run that because it's like already in use. Similarly, wanted to create a container on the same 880 like VM4, right? On which port number? The same 8002.
Yep.
But 8000 already in use, so we cannot do that. Here we are error message.
Yeah, it's already bind.
Yeah, you need to change that. So that's like process, that's like a way. Clear with that?
Yes.
Right, so process and all the remain same, right? About this container, so containers, Docker, what we can say, to run, to deploy your application, we have a mechanism. We can create an applications, or we can deploy an applications quickly, or we can say with the help of single command without doing all these process. We can say the traditional method, or we can say the virtualizations. We have a container images, we have a pre-inbuilt application, all those things, right? It will use that kind of process, that kind of resources that admin required to run those applications, that are not going to use any unwanted process. Even though when you're talking about the physical machines, right, that is my physical machine, let's suppose that, and there is a lot of unwanted application running on that, unwanted, if you notice on that, right? If not sure about that, then you cannot use that. There are some unwanted process that are running on inside these machines, right? But when we're talking about the containers and all those things, let's suppose that we have a container, any container we can say. Let's suppose I'm just switching the public VM, right? So in that case, that process are going to run that you execute or your admin execute that, right? If you notice now, like when we run this command, like top command and all those things, okay, so what process that are running inside there? We have only 6 process, and all those are bash and apache that we start earlier, right? Even though if you run the command ps, we have only these process. So depend on that what process you want to execute that. But in the case of our traditional method, or in the virtual, that process should be run. If you kill those process, that might be problem with your OS and all those things. But in the case of container, it's not required, right? System automatically detected which process required, which application required to run those applications smoothly. Clear?
Yeah.
And another process remains same. Wanted to stop something, right? Then you can simply use stop command, like Podman wanted to stop, so you can use Podman stop, just like a same method. You stop and then your machine's name, like let's have a public, right? If you notice now, okay, if you notice now, here in my case, the process is not running, it's in the stop status, right?
Yeah.
In -a it show that we have a and application this existing 5 seconds ago. Okay, wanted to start that, then simply you can use Podman start, and then the public VM. Okay, so within a second you can start, you can stop, and all those things. That's like process, that's like a way. Done. Wanted to remove those, simple you can use rm and then the command name, right? But again we are error message. Why? Because this container are in the running state. Wanted to delete, wanted to remove, then stop and delete. Either you can simple force it.
Yep.
Clear, right? So Podman rm VM3 and 4, then you will remove that. Podman ps, you have not running those containers, right? Wanted to remove all the container at the same time, then you can simply use rm-a and forcefully. It means what? If is there any running container, then we are going to delete that, right? Wanted to stop, then you can stop. Wanted to start, you can start. Wanted to restart, you can start that, right? Wanted to remove rm-a force.
Yep.
Clear? So we don't have any running container, we don't have any stop container, and Podman RM I and then your images name. So I want to remove all images. You can simply mention -a again. So we have like all the images are going to remove that. So we don't have any images yet. Okay, and then we don't have any container, running container or stop container yet. That's all. That's a process. Clear with that?
Yes.
So these like a way, right? But problem what we have that we have, if we have like multiple containers, then we cannot manage and maintain those containers with the help of Docker command, because Docker or container allowed to create or manage a single container at a time, right? If I wanted to manage more than a container, all those things, what I need there, I need kind of some orchestrations tool, we can say, right, that allow or that help to automate or automatically self-heal or manage your containers and their resources. Correct, right?
Yeah.
Yeah. Now, so before start this OpenShift and all those things, right? Let me show. So you guys have a lab for the same? Not yet.
Uh, we registered and we created the account and
Over the
shared
Red
that
Hat, you
with,
created the account.
yeah, and we shared those
Yeah.
details also, but
Authentications
we
to the
don't,
Mac. Okay.
yeah,
Okay.
but we don't know how to
Okay. So
generate
might
account.
be the coming week. The coming week might be enabled, right? Because in the weekend, they Red Hat will verify
Okay,
all the
okay.
authentication, so that could be a problem, right? But no
Yeah,
worry.
yeah.
Might be
Okay.
in the coming week that your account will activate. Not a problem.
So
Okay.
this account we need to access only from Red Hat, or we can set up on our own VMs?
So for the same, if you wanted to configure your own OpenShift infrastructures, I mean, we can say the lab, right? We need some large hardware requirement. We need that at least, right? We need at least 16 GB RAM, 3 machines we need at least to configure these kind of environment.
Okay.
What they recommend that, right? Because we have some
Mhm.
lot of dependency, lot of package we require to run an applications, right? So that's not running on the like 4 GB, 8 GB, 16 GB RAM as well. We need at least 16 GB RAM because we need a two types of machine, worker node and master node,
Mhm.
right?
Yeah.
So at least for the practice these environment, we need at least three system, right?
Mhm.
Two worker node and one master node,
Master
right?
node.
And yeah, and each and every machine we need at least 16 GB of RAM.
Mhm.
So that
Yeah,
is
yeah.
not in our lab environment and all those things. So that's why either you can just use from any cloud-based environment, like from the AWS and all those things, right?
Yeah.
Either if you have an on-premises lab and all those things, then you can use in that way as well, right? I'll show the example, not example. If you wanted to create your own lab, right, then you can
Mhm.
follow these content, right? These documentations, right? So similarly,
But it will be even if I will deploy that on-prem by
on-premises.
provisioning those, yeah, on
You
premises.
can you can deploy it, not a problem. All the
Yeah, yeah,
steps
but
are.
will it be trial, right? I mean, since it is enterprise version, so it will
Yeah,
be
it's a
trial, right?
trial version. You don't have a support and all those things, right? If you wanted to
Okay.
switch on that, then again you have option. You can switch, not a problem.
Mm-hmm.
Okay, yeah. So again, like these are steps you want to deploy on the Alibaba cloud, on the AWS cloud, Azure cloud, and even though the GCP and then IBM cloud, and on the bare metal, these are steps. Okay, want to deploy on the bare metal. So what I need that these are steps required on the bare metal. Okay, so what they mentioned that we need these machines, okay, minimum with these requirement, right? So we need the 4 core of CPUs, okay,
Mm-hmm.
and at least 16 GB of RAM for each and every machine. So that's like possible to deploy those things, right? So the step are they clearly mentioned that want to deploy on the AWS on all those things, right? So these are steps are mentioned there, every step they
Okay.
mentioned there, right? You guys can follow these documentations, right, to set up the lab and all those things, right? So that's why Red
Okay.
Hat recommend that if you are a learner and all those things, right, use that particular the Red Hat lab. Actually this like a smooth and all those things, but again, if you wanted to know the process how to configure or how to install the OpenShift lab, then you guys can follow those documentation, not a problem,
Okay.
right? Yeah.
Yep.
So the lab environment are remain same. Not like we have these machines. So we are not going to discuss all those things now because you guys, I mean, your lab is not activated yet. But again, I'll
Yeah.
just simple quickly not let you know. So in the Kubernetes and in the OpenShift, what I need then, we need at least two types of machines, right? One I need a Kubernetes, right? And one I need a OpenShift. Sorry, sorry, in the Kubernetes, or we can say in the OpenShift, we need a two types of system,
But sir,
right?
what is what is major difference in this OpenShift and
Okay, so in the
Kubernetes?
Kubernetes and OpenShift, the difference we can say, the first one it's like open source project. Okay, we don't have a, like much support. Like if you are a working professional, you know the concept, then you can troubleshoot, you can check the blocks and all those things to fix those error and all those things,
Mm-hmm.
right? That's like a possibility. Another hand, we can say there is a lot of extra, and in the case of OpenShift, it's like enterprise level application and all those things, right? When we're talking about some extra behavior and features, so then OpenShift have a lot of another extra feature related to your securities context, right?
Okay.
That in the case of in the case of Kubernetes, that is not by default available, right? In the both way, in the case of Kubernetes, in the OpenShift, we have a two options. Either you can use the command, either you can use your dashboard, I mean GUI mode to manage those application. But GUI is like much better than the in the case of OpenShift, that's like much better than the Kubernetes,
Mm-hmm.
right? So to automate for the DevOps automations, for the DevSecOps operations, Kubernetes are OpenShift are mostly used because there's a lot of features, lot of behavior, lot of OS dependencies as well. Because Kubernetes, they recommend that you can deploy any kind of operating system, right?
Yeah.
In another hand, when you're talking about the OpenShift, right? OpenShift, I mean, Red Hat recommend that we are mostly preferable on the RHEL-based OS, right? And most of the large IT company using the RHEL-based operating system because they have
Mm-hmm.
a
I agree.
support and all those things, right?
Yeah.
So they recommend that we customize these application, I mean your OpenShift application in that way where we can integrate your OS plus applications. We have like some SLNX policy that is not available inside your Kubernetes. Then we have a SCCs and all those that is not available inside your Kubernetes, right? We have a lot of extra security features, admin features inside this particular OpenShift.
Okay.
We'll
So
discuss in the single, yeah,
it is like iPhone and iOS.
something like that, we can say.
Mm-hmm.
So there is a lot of extra features, security features, because there's like a customize and all those things. So mostly in the productions, for the development and all those things, we have a Kubernetes. Not about that. So depend on that. If you have any like process, you want to understand that how your application will execute and all those things, then you can go for the Kubernetes, right? But the support and all that, there could be a problem. Similarly, in the OpenShift, we have an enterprise level
Mm-hmm.
support. If your company wanted to switch, they can switch that. That's a point.
Yeah, yeah, yeah. Our company is also trying to switch because one limitation we got from Kubernetes. Support
Hmm.
is there from Kubernetes also because Rancher, Tanzu, they are
They,
providing
yes, they are,
out of the
yeah,
box. Yeah,
correct. They are like we have like, so even though in the open source there are a lot of different providers.
yeah.
When we're talking about the official provider and all those things, in the case of like Red Hat,
Hmm.
or when we're talking about the OS and all those things, so
Yeah, but
they. Mhm.
why we are switching? The main
Mhm.
reason was this other Kubernetes open source enterprise or even KubeADM. They are
Mhm.
just providing per node 110 pod limit. OpenShift providing around 200 plus. So that is the
Correct,
one reason
correct,
our organization is trying to switch.
correct. Even though you can also scale those things.
Yeah.
Even though you can also scale those things depend on your requirement and all this, because you guys are using, might be if you are using a license and all those things, then you can scale because it's like a customizable, so that also you can customize those things. So a lot
Yep.
of feature we'll discuss that. So that's mostly the large IT are using the OpenShift product and all those things. This depend on that, right?
Yep. Yeah.
Yeah. So yeah, so in the both the container management tool, we have a two types of machines. We can say master node and worker node, right? Or we can say we have like master, and then we can say we have a worker node, right? Master is nothing, we can simple say like our control plane. We can say that type of machines, right? Where we can, from where we can manage and maintain all those things, right? And then worker, what we can say, that type of machine that hold your all the containers, or we can say that hold all your pods, right? So we'll discuss that in the next sections, not now because your lab is not activated yet. We'll discuss that, right? So we have a machines like we can say we have a master and worker for now. In my case, we'll discuss that we have like all this machine that could be a master, worker, and all those things, right? But again, wanted to create an application and all those things, we can switch with the help of master, and then also we can switch with the help of worker node as well. I wanted to verify those things. Just a second. Okay, so in my case, actually, we have a 3 master and 3 worker. Wanted to verify, then I can use simple OC get node, or you can use the kubectl get node as well. Even though this command also going to work inside that, not a problem.
Okay.
Okay, so in our lab we have a 3 master and 3 worker because we don't have any lab max lab availability. That's why. But in the real world, what we have that we have a master and then we have worker node, right? Always
Okay.
recommendations: do not schedule or do not create any pod or container over the master because it's like a managing your entire Kubernetes or OpenShift infrastructures, right? All
Yeah.
the component and service are going to launch or create over the worker node, we can say, right? Wanted to check in the detail, then we can describe nodes. Let's suppose on my master, let's suppose master 01, so you can also verify those things. Let's suppose these are stages what they are mentioning there. So these are my system information, these are like labels, okay, and the name, okay, and the all the resources and all those things. So kubelet has enough memory, no disk pressures and all those things, that have enough process ID, okay, that they have a name, they have a IPs, they have a CPUs and all those things, we have a RAM and all those things, okay, which OS they are using, that they are using a RHEL core OS, okay, which kernel version they are using that, and then the container runtime cryo, if you notice on that.
Yeah.
Okay, and then the Kubernetes, which version they are using that. You can check from here as well, either when you run this command like kubectl get node, even though you can check the Kubernetes version as well.
Yeah. In that describe output, do we have per node limit? I
Limit,
never saw in OpenShift, so
limit
that's
means what
asking you.
limit?
Per node pod limit.
No,
Some
it's not
some.
mentioned here actually.
Okay. I thought they may be mentioning. Okay.
No, they are not mentioned actually, but again, you can specify those things. Clear?
Okay. Yeah.
We'll discuss that. We have a different options for the same, right? So the lab environment, and so like today what we discuss, actually what we discussed simple about the what is the container, and the different mechanisms, Docker and Podman, right? And why we're going to use the Kubernetes and OpenShift depend on your requirement and your availability, or we can say to automate your container infrastructure, we can automate our environment. Okay, the
Yep.
next day the lab and all those things we'll discuss the next day, okay,
Yep.
when your lab is
Agree.
activated, so accordingly we can start that.
Yeah.
Okay, so
Sure.
if any questions so far, then you guys can ask that, and then we will just wrap up for now, okay? And after this session, just share me your LMS account username, okay? So what I can do, I can simply upload these this recording over there, okay? So you guys can go through anytime whenever you want it. Okay,
Okay. So you pasted that ims.webasha on that. We need to
LMS.
create account LMS. Okay.
lms.webasha, okay, and then we'll just create your account over this portal, and then share me your username. Okay,
Usernames. Okay.
yeah, yeah. Might be email ID, that's your username. If you wanted to share, you can share that, the same email ID. Okay,
This is my username, and this is my email address.
if possible,
You
then you can
you
share over
created
the,
Vijay. Sorry. Go ahead, please.
yeah, if it's possible, then just share over the WhatsApp or some group you guys created that, right? Then it will be great if you can share with the WhatsApp, because when we just end of the session, that message will delete that, okay?
No, we
So we'll
don't have
in,
your number to create
okay,
WhatsApp
I'll
group.
drop in over this message.
Is it ending with 227?
227, correct.
Okay.
Simple drop me a message over there, right? Your email and your email address is required, okay? I'll approve from the backend. Okay, yeah.
Yep, got it.
Okay, then we'll start. Yeah, I got your message. Vijay, okay.
I will register and then I will
Sure, sure, not a
message you
problem.
there.
Just share, yeah. After research, just share me your email addresses. Okay, yeah.
Yeah.
Okay, then we'll start next day, yeah. And let me
Next
know if you need
Saturday,
help.
right?
Next
Saturday,
Saturday,
right?
next
Yeah,
Saturday,
sure.
right?
Got it. Yeah.
Yeah,
Okay, sir.
yeah.
Thank you.
Okay,
Yeah.
yeah. Bye bye.
Bye.
Yeah.
Yeah.
Okay.
Okay. Thank you. Bye
Yeah.
bye.
Bye bye.
Bye.
Yes.